Greetings everybody, myself Pulkumar Patel. Welcome to LeetCode problem solving series. Today we are going to solve the question, today's daily question 3121, count the number of special characters 2, which is a type of medium question. So we'll start by understanding our problem properly, then moving forward to the brute force approach for solving the problem, and at the end of the video we will solve the today's daily question in the most optimized way possible. So let's just go for understanding what our problem is trying to say. So first of all, we are given an input word which contains lowercase as well as uppercase letters only, as mentioned in the constraints, that it contains only lowercase and uppercase letters, English letters. Now what our task is that at the end of the code we need to return a count. Now how and what count will it be containing? See, we need to return the count of special characters or the special letters which are present in the word. Now what are special letters? Let me just give you an example so that you can gain a proper understanding what are special characters. So we have our first test case of this problem, which is this one, complete given. Now let me just show you what is a special letter. Let's say we take A in our consideration. So as you can see, A is present in this word named string in the form of lowercase as well as uppercase letters also. So what a special letter is that, now as I took an example A, so A, there are mainly two instances of lowercase type of A, which are this two. Okay, like there are mainly two times for which A comes in its lowercase form, as you can see here in the complete given string. There is no small a after these two, okay, and its uppercase form of A comes after this only. Like there are two instances which are coming before A. So now we know that yes, the first uppercase of A is coming after the last lowercase of A. Okay, this is the actual definition of a special letter, that if a letter's uppercase form comes after its own lowercase form, then it is known as a special letter, which is present in here. As you can see, the last lowercase form of A is here, and the first uppercase form of A is here, which is after the lowercase form. So A is a special character. So now we will gain our count as 1. Similarly, the first uppercase form of B comes here, which is after its last lowercase form, which is one and only the small b. So B is also a special character. So we will increase the count by 1 again. And similarly, for the last character, the C also comes, the uppercase form, first uppercase comes after the last lowercase. So C is also a special character. So count equal to 3. So at the end of the code, we will return 3 for this type of test case. I hope you understood what I'm trying to say. This is the actual complete definition according to this problem of a special letter. That if the first lowercase, mind it, first lowercase form of a letter comes after its last lowercase form, then that letter will be considered as a special letter. And for this problem, at the end of the code, we need to return the number of special characters or letters which are present in that inside the word input string. Okay, so this is our complete given problem. So now let's solve this problem. Let's just move to the brute force approach for solving the problem. So first of all, as we know that, see, first of all, we would be needing to iterate from A to Z, because we know that yes, we are having 26 set of letters only. We have only A to Z letters, so we can easily iterate from A to Z. Now, why we need to iterate through each and every letter? Because we don't know if the letter which will be encountering, we don't know if its uppercase part is going to be there or not. We also don't know if its lowercase part is also going to be there or not. So instead of iterating through word string, because let's say we start iterating through the word string, then what will we going to do? We can't literally do anything, because if we take a single letter, then for checking if its uppercase part is present after it or not, we need to do again iteration from start to end. So for that itself, we would be needing a single. So for that type of nested checks, we will be needing more and more nested loops. So it will be too much like redundant for a for loop, and obviously it will not pass through large test cases. So instead of doing that, what I'm thinking is that let's just first of all have a int count which will be returning at the end, which will be initialized as 0. Now, as I mentioned, let's just iterate through a complete set of characters of from A to Z. Okay, so that we know that yes, if any letter is there in the string, then we will be processing according to our given condition. But if we don't have that letter, then simply move to the next letter. We know that yes, there are only going to be 26 iterations. Why? Because there are 26 letters. Okay, so simply we can, like that way, we can limit the number of iterations instead of doing it infinite for large test cases. So here it will be char ch equal to small a to small z. So here it will be small z, and again we will be doing ch plus plus, like moving forward from A to Z. So 26 iterations fixed. Now during that iteration, what we are going to do, what we need to do according to condition is that we need to first of all we know that overall we need to compare if our last lowercase letters is before the first uppercase letter or not. This is the simple comparison or simple task that we need to do, which is compare if the first uppercase is after the last lowercase or not. So for that comparison, obviously we will be needing the indices of last lowercase and first uppercase, so that we can simply check if the last lowercase index is less than the first uppercase index, then we know that yes, it is correct, and increase the count by 1. Okay, so for gaining the indices of the lowercase form and uppercase form to compare at the end, we will first need the indexes, for which we will be simply iterating through the complete word string inside this loop, again like using a nested loop. And during that iteration, we will simply check if the lowercase form of the current we can say character is present, then store its index inside a integer. And again we will be using another loop, like after the main loop we will be using another loop to simply check if the uppercase form of the current character is present, then again store its index in another integer. And after the completion of both that loops, we'll simply use an if condition inside this loop itself to check if the indices of lowercase is less than the uppercase, then simply increase the count. Okay, this is the overall approach, like overall explanation of the approach that we are going to use inside this for loop, the condition that we are using here. So let me just go for it. Let me just go there. If anyone is not understanding what I'm trying to say, I will explain again during the code writing. So let's just move to the code writing part. As I mentioned, first of all, we will need two integers, one for storing the last lowercase index and one for storing the first uppercase index. So let's just name it like that itself, last lower, and it will be -1, because we know that yes, if there is no index present of a letter, it will be -1. And first upper to store the uppercase parts index. So as I mentioned, first of all we will be processing, like finding the index of the last lowercase form of the current character, for which, as I mentioned, we will be using a nested loop, in which we will start by iterating through the given input string, and during that iteration we will simply check if our current character is equal to the main loop's current character, then we know that yes, it is our lowercase form of, we can say, the current character. So store its index in the last lower. Now many of you would think that how this can help us to calculate the last lowercase index. So you know that yes, if there comes a character, like let me just dry run this loop for this test case, so that you can know that how this like stores the last lowercase index. See, if we start by iterating from this part, okay, then we have a, so it will store a, because we are currently starting the iteration itself. So a's index, which is 0, will be stored in last lower. So last lower equal to 0. Now the next letter, the exact next letter itself is also a, so it will change, this last lower's value will change from 0 to 1, because we are running the loop even after storing. So it will similarly go till the end, and then it will know that yes, there is no a small lowercase form of a coming after this first index. So it will store 1 as its index in the last lower. So like this way, every character's or every letter's last lowercase form's index will be stored in this variable named as last lower. Okay, so after this loop, we know that yes, we are having the last lowercase letters index in this variable. So after that, our task is to access the first uppercase letters index to compare at the end. So for that, again, as I mentioned, we'll be needing another loop, in which again we will be iterating through the complete given string. And during that iteration, we will check if our current word of I is an uppercase form of the current character. Now, for that, like for checking if the current character is the uppercase form of the main loop's current character or not, for that we will simply do a mathematical operation as a part of trick, which is minus a plus capital A. Now how this will work? Let's say we are having a capital B. Okay, now for converting our small b, because we know that yes, our current character for the main loop is a small b. Okay, so for converting, or we can say using the small b in the like converting it to the capital part, we need to subtract 32. Okay, because we know that yes, the small b's ASCII value is coming after the capital B's ASCII value, and the difference between the capital B's ASCII value and small b's ASCII value is 32. So for we can say subtracting 32, we can simply do this operation minus a plus a, because this can help us by doing plus 65 minus 92, or sorry, minus 96. So plus 65 minus 96 gives us minus 32. So this way we can simply subtract 32 in the form of ASCII value, because if we write, now many of you would say, why don't you just write 32 like this? Because we can't write, because ch is a character and 32 is an integer. So you know that yes, we can't subtract an integer from a character. So for subtracting 32 integer in the form of a character, we need to write it this way. Okay, so that now we are dealing with ASCII values. Okay, so this way we can simply do this operation of checking if our current character in the word input string, if that's equal to the main character's uppercase form, then simply we know that yes, now we are having the uppercase form. So simply store its index in first upper and then break the loop. Why we are breaking this one? Because we are not doing it here. We were not doing it here in this one loop, because we will be needing the last lowercase. So for getting the last lowercase index, we need to iterate from the start till the end, so that we can know that yes, the last lowercase is this one. Okay, because there are many instances of the lowercase before this one. So for getting to the last, we need to iterate from start till the end. But for the uppercase part, we know that yes, we only want the first one which comes. There is no need to do anything with the rest parts, rest uppercase forms. So for skipping them, we just need to break the loop, because we know that yes, if we are encountering this character of a word, any random character, if that is the uppercase form of the current character, then we know that yes, this is our task. This is what we need to find, the uppercase form of the current character. So rest, we don't have to do anything with the rest letters. So we will simply break the loop by using the break keyword. Okay, I hope you are understanding what I'm trying to say. For then too, let me just I will just dry run for you after completion of this process. Okay, so as I mentioned, after getting last lower and first upper, we will simply use an if condition to check if the first upper is greater than the last lower. Also with that, if we are not encountering any character which is completely empty, because we don't know, let's say in this main loop we are going to have an iteration where ch will be equal to z. Now z is not present in this one, so for z, the last lower and first upper both will be -1 at the end of this loop. So for checking that type of edge cases also, where we don't encounter any type of digit, we will simply check here that if first upper is not equal to -1 and last lower is also not equal to -1, then we know that yes, it is that character is present inside the word. So we will then simply know that yes, our first uppercase's index is greater than the last lowercase index. So for that type of cases, as I mentioned, according to condition, we will simply increase the count by 1. So count plus. Okay, so this way, at the end of this main loop, we will have our complete count built from the scratch according to our given condition. Now, before moving to before running this code for the main test case, let me just try run this code for viewers who have still not understand. See, let me just take this test case only. Okay, so first of all, our code, like our main loop, will start from ch equal to a. So for a, okay, as I mentioned, our last lower will be -1. Now this loop starts running, so our first character will come, so it will be a. So we know that yes, a is equal to a, the last lower. So last lower will be initialized to 0 from -1. Okay, now coming to the next iteration. Next iteration is also an a. So the last lower will change itself from 0 to 1. Okay, changed after that next iteration. Now other iterations, for every next iteration we don't have a small a. So at the end of this loop, we will have our last lower equal to 1. Okay, moving to the next loop. Now for the next loop, our a, capital A, will be encountered at this third iteration. So for this third iteration, our first upper will be initialized to 2 from -1. Like it will be changed from -1 to a 2, a integer 2. So we know that yes, our uppercase letter is encountered now. Like we know that yes, this is our first uppercase. So now we don't need to do anything with this rest letters. So we'll simply break the loop, and at the end we'll simply check that if our first upper, which is 2, is greater than the last lower, which is 1. So 2 is greater than 1. Then yes, other end will also run, and we know that yes, first upper and last lower, none of them is equal to -1. So we know that yes, this if condition is exactly correct, and we know that yes, now our condition works and a is our special letter. So we will increase the count by 1. And similarly for b as well as c, the count will be increased to 1 by 1. So at the end of this complete loop, at this line, we will have count equal to 3, which will simply return at the end of the code according to our condition. So I hope you understood how this code works. Let me just run this complete given brute force code for the input main test cases which we are having. Let me just run the code. So yeah, it perfectly works. Let's just run this code like by submitting to check if this code works for the internal edge cases or not. So let me just submit the code. So yeah, it perfectly works as you can see. But obviously the memory is showing it efficient because we are using maybe less number of space. But the time, as you can see, it just beats 5% and it is taking 213 milliseconds, which is obviously too much high. It's like at the end of the graph. So obviously it is a brute force approach. So due to that itself, the time complexity is too much. So this is our complete brute force approach for solving today's daily question. Now let's just move to the optimized solution for solving the problem. So let me first of all just delete this much. Okay. Yeah, we will obviously need a count which will be returning at the end. So let's just now move to the optimized way for solving the problem. So first of all, we will obviously don't iterate from A to Z, obviously because we can't do that. It will fix our iterations, and after that inside itself, we are also using 2 nested loops. So it will obviously cost us too much time. So instead of doing that, what we can do is in the optimized approach is that first of all, we will be using like you saw here that our space is too much optimized, like it is too much high, too much better, and our time is too much low. So in the optimized approach, what we'll be doing is that we will divide this times complexity into sum of space and sum of time. Okay, I hope you understood. Like instead of taking too much time and too much low space, we will take some space and some time so that both of them are stayed optimized according to our problem. So let's just move to that part. So for doing that, what we can do is that we can use vectors. Now how this can work, let me just show you. So what we will be doing is that we will have a vector, okay, of fixed size of 26, we can say positions. Okay, and in that 26 positions of the vector, we will iterate through the complete given word string, and during that iteration, according to the letter's position, we will store the last lowercase index inside that vector. Now how this will work, let me just give you an example. Let's say we name our vector, which I am mentioning as store. Now as I mentioned, we will initialize store by fixing its values as 26 fixed positions, and everyone will have its value initialized as -1, because we know that there is no index in the start of the code, so it will be obviously -1. So we will have this way, like -1, -1, okay, -1, and similarly we will have -1 till 26 positions. Okay, this way our store will complete 26 positions, 26 elements, which all of which will be initialized as -1. Now, how this will store the last lowercase index is that we will do that while iteration. Okay, we will take this a as 1. So we know that yes, a's place value in alphabets is 1. So we will we can say subtract a from this a itself, which will give us a 0. So what I am trying to say is that we will iterate through the given input string, and when we encounter the last lowercase form of a letter, we will take its index and then store it according to its position inside the store. Now let me just dry run for you to make you understand what I am trying to say. If we will start by iterating through a. Okay, now a's positions is we can say 96. Okay, so when we do it this way, word of I, okay, word of I minus a. So what this will result in is that okay, let me just do it this way. What it will result in is that we will start by iterating, so we'll encounter this a, so it will place a in place of here. So a minus a is equal to 0. So what we'll be doing is that store of word of I minus a. Now how this will help us is that it will help us to do store of a minus a. So a minus a is 0. So store of 0 is equal to the current index. So this way a's index, which is 0 right now, will be stored at the 0th position of store. So here it will be stored 0. This way for the next iteration we will again encounter another a. So a's index is now 1. So now store of a minus a is again 0. So it will store 1 in place of 0 here. This way for each and every character we are taking the last lowercase index and storing it inside this store according to its alphabetical position. Okay, I hope you understood how this complete store vector will contain, like it will store every letters from A to Z's last lowercase positions, last lowercase index, again which we'll be using at the end of the code to compare with the first uppercase index. Okay, so let's just check this part first. Okay, as I mentioned, we will have a vector which will be integer. Okay, and it will be named, as I mentioned, store. And as I mentioned, we will iterate through our complete word, the input string, and during that iteration, word dot size. During that iteration, as I mentioned, we will do it like this way: store of word of I minus an a is equal to the current I. This way it will store every letters from A to Z's position inside the store vector according to its respective alphabetical position, as I mentioned and give you an example just now. So this way at the end of this for loop we will have every letters from A to Z's last lowercase index present stored inside this complete store named vector. Now after storing that, what our task is that we now got last lowercase index. So for comparing it with the first uppercase, we will now need the first uppercase index. So for getting that index, we won't be storing that index. We will be directly accessing it by iterating through the word. Now how this will work, let me just show you. Okay, first of all, what we'll be doing is that we will start iterating from the word. Let me just remove this part, okay, for better understanding. Okay, so now we know that yes, store is having every letter's last lowercase position stored inside the complete given vector. Now what we'll be doing is that we know that yes, there are duplicate characters too inside the word. Okay, here as you can see, we have a number of duplicate letters. So what our task is that we need to check if our current uppercase is first or not. Like, we need to check if our current uppercase letter that we are currently on, if that's already came before any iteration or not. If we let me just give you an example. Let's say we have an A here also, okay, in this word. So let's say we are at this iteration. So we need to check if this A that we are currently on is already present anywhere before this iterations or not. Okay, so this way we can know that yes, if our current uppercase is first or not, like it's already there before this current character or not. This way we can simply check if our current character is first or it has already been duplicated before this one. Okay, I hope you are understanding what I'm trying to say. So for checking that if it's already came or not, we will again use another store vector, store2, which is again a vector, but it will contain characters. Now how this can help us is that for every uppercase letter, we will store it inside the store. So let's say we are at this A. So we know that yes, if we are trying to find this A inside the store2, then it will give an error. Why? Because A is still not present inside this vector. So if we know that yes, if this finding this A gives us an error inside this store2, then we know that yes, it is our first uppercase character. So then we will simply check if that index of the first uppercase is greater than the last lowercase, then simply increase the count. Okay, I hope you understood what I'm trying to say. For every uppercase letter inside the word, we will simply check if it is already present inside this store2, then don't do anything, move to the next character. But if our current uppercase letter is not present inside the store2, then we know that yes, it is the first uppercase letter, the first instance which we need to use to compare. So we will take its index as I, and then we will simply check it by using the store that we are having, inside which we are having the last lowercase index. So we'll take the current I, which is our first uppercase index, and then we'll use the if condition to compare it with the last lowercase index which we are having inside the store. Okay, I hope you understood what we are doing and how we are going to solve the problem. Now let's just code for this as I mentioned. Okay, if you didn't understand, I will again explain by doing the dry running part. Okay, as I mentioned, let's just iterate through the complete string again for checking the uppercase letters. So I plus plus, and during that iteration, as I mentioned, we will be needing another vector, okay, which will contain characters in it. So char, and let's just name it as store2 itself. So inside this, as I mentioned, first of all, each and every check that we are going to do, or every process that we are going to do now for uppercase, that will be only and only done if our current character is uppercase or not. Then for that itself, we are going to use a if condition. If our current character is uppercase, then and then only do anything that we need to do, the process. Otherwise, just don't do anything. If that's not uppercase, then there is no work that we need to do. So we will be just skipping that part, the current iteration, and move to the next iteration. So from capital A to capital Z. So now we know that yes, our current character, that it's a capital letter. So now, as I mentioned, now we will use the find named method. Okay, as I mentioned earlier, we will be using the current character that we are on. If it is a uppercase letter, find it inside the store2. If it's not found, then we know that yes, it is the first instance and we need to use it to compare. But if that's found inside the store2, then simply move to the next iteration. Okay, this is the simple process. So for that, we will be needing the find method. Okay, now how find method works. In find method, what we do is that we mention the start index from which we need to find. Okay, so here word dot begin. Okay, word dot begin. Okay, and word dot end. So from start iteration to last iteration. And what we need to find? We need to find the current uppercase character, which is word of I. Okay, so now how find method works. Okay, find method works is that if an index is found, okay, then it will return the current index, like the index at which the current character is found. But if the index is not found, then what it will return is that in JavaScript, find return we can find returns -1 if the current character is not found. But if in C++, if the current character is not found, then find method returns this word.end. Okay, why? Because the last index, after the last index, we don't have anything, which is an empty character. So if we know that yes, if our current character is not found inside the word string, then it's an empty part. So it will return that empty part inside C++. Okay, as I mentioned, in JavaScript, if our current character is not found, then it will return -1. But in C++, it returns word.end, which is its property. So this way, we can simply check if our current character is not found, then it will give us a word.end. Okay, and if it gives a word.end, then we know that yes, our current character is the first character itself, like the first instance of the uppercase letter. So if that's the point that we need to check. If it's the first instance, simply check if its index, which is I, if its index is greater than the last lowercase index, okay, present inside the store, then increase the count. Now for accessing the last lowercase index, we will do it by this way: word of store of, okay, store of current word of I minus a. Okay, here it will be capital A. Why? Because if we have a capital A, okay, let's say we have a capital A, so capital A minus capital A will give us a 0, at which the last lowercase index is present of A. Okay, so this way we can access the last lowercase index of our character, uppercase character, that we need to check. So we'll simply check if our current index, which is the most unique or the first instance of its uppercase form, if that index is greater than the last lowercase index, then simply increase the count plus. Okay, so at the end of this loop, we will have every count of the special letters which we need to find. Okay, how? Because we are using this way, that if we are finding that, let me just dry run for you, okay, for better understanding. Okay, see, as I mentioned, at the end of this code, we will have the last lowercase index of every letter from A to Z stored inside the store named vector. So after this loop, what was is that we will start iterating again from A. So A is a lowercase, so nothing will work. No if will work. Okay, next A is also small, so no if will work. This is an uppercase part. Okay, let me just, yeah, this A is uppercase. So now the actual if will run. Okay, inside if, it will know that yes, it is an uppercase. So inside if, again, we will use the find method. So find from word of begin to word of end. Okay, I'm really sorry. Okay, I have done a mistake here. Here it won't be word, it will be store. Okay, because we need to use store, okay, to find if that's present or not. So from store to's begin to store to's end, find if the character which we are currently at, which is this A, if it's present or not inside the store to. If it's not present, then it will give us a word.end, as it's here also it will be store2.end. So yeah, it will give us a store2.end. So now we know that yes, it is the first instance of the uppercase form. So we know that yes, now we need to compare, okay, the current index with the last lowercase index. So we are doing the same. The current index I, if that's greater than the last lowercase index present inside the store, then increase the count. Okay, similarly, now the code is still not completed. Okay, why? Because after, let me just first of all complete the dry run. So after this, every iteration, we will encounter this A again. So at this A, we will know that yes, our A should be stored, okay, inside the store too. Otherwise, what it will do is that it will run this, the if condition will be running for this A also. Why? Because we aren't pushing the current I inside the store too. So for pushing that, at the end of this if, okay, like this if, we need to push that if the find is we can say like it is giving us dot end, then what we need to do, okay, this else will not be needed. Why? Because if this if will run, then we will simply store it. Store to dot push back the current character, which is word of I. Okay, done. So after this if will run, we are going to push the current character inside store2. So that it can help us check for this A. Okay, this second A, the second instance of capital A. Why? Because at this instance, store2 will be having A in it. So this if will never run. Why? Because this will give the index of the first A. So this if will never run and count will never be increased. So this way, at the end of this complete code, we will be having our actual count of the number of special letters. Okay, so this is the complete optimized approach. Let me just run this code for the main test cases if this works or not. Okay, I hope you understood. Okay, this is too much complex. Okay, there is some error. Let's just check what is the, okay, at line 9 we are having a null pointer error. Okay, at line 9 we are storing index. Okay, yeah, okay, I got it. See, really sorry, I just forgot to initialize the store. Okay, I mentioned this in the dry run that we are going to initialize store with a fixed positions, which will be 26, because we are going to store every letters from A to Z's last lowercase index inside store, for which we will be needing a fixed positions, which is 26. Okay, I mentioned this during the dry run, but really sorry, due to some like nervousness, I forgot to mention it inside the code. And obviously we will be initializing it not as -1. Okay, I mentioned that as -1 during the dry run, but what if we mention it as -1? Okay, if we are initializing it as -1, okay, the letters which are not present inside the word, that will also give us, like, it will also be counted here inside this if we can say condition. Okay, how? Let me just write it for you. Okay, I will just explain. It will give an error. Also, I forgot one thing here also. What? That we need to process this complete part only and only if our current character, or we can say current letter, is a lowercase. Okay, if that's uppercase, why we need to store it? Okay, this is again a mistake that I did. I'm really sorry for that. Let me just rectify that. Okay, here it will be small a and word of I less than small z. Okay, this way, if our current character is a small letter, small lowercase letter, then and then only we need to store. Otherwise, we don't need to do anything according to our condition. So this again also, this will not work for the third test case. Why? Because z is not present inside a word string. So z should not be processed in this complete if. But if we are doing it as -1, it will process. Why? Because here we are, if I is greater than this, and this contains -1. So current I will be obviously greater than -1. Okay, so it will give an error to us. So instead of doing -1, what we can do it here is int of max. Now why this can work? If our current character, okay, let's say we are having a capital C, okay, inside this third test case, but we don't have a small c. Okay, so this complete letter should not be processed. So if we use int max here, okay, c will be initialized like c's position, which is the third element inside this vector, because a, b and c. So third position will be initialized as int max. Int max is the highest value present inside the complete C++ language. Okay, it is the max integer value. So it will be initialized as int max. Now c is not present, like small lowercase c is not present inside word. So after running this loop, the c's position will still have int max. Okay, now inside this loop, if we are encountering this capital C, so this if when run, it will check if current I, which is the 3, C is at 3 index inside this word. So 3 is not greater than int max, because int max is the max value. So let's say we initialize it as -1. Obviously it will give an error. Why? Because small c is not present, then too it will work completely, because 3 is greater than -1. So for dealing with that type of edge cases, we need to initialize this as int max. Okay, and again I rectified this too, that this if like this loop will help us to store perfectly the last lowercase letters, for which we'll be needing this if. Okay, Really sorry. During the coding part, I was like a bit nervous. So due to that, I just forgot that part. Really sorry for that. So now after rectification, let's just run the code for the main test cases. If that works. So yeah, it perfectly works. Let's just submit the code now. If that works for our main edge cases, the internal edge cases. So yeah, it works perfectly. Okay, it gives less memory, but the runtime is obviously, as you can see, it's better than the previous part. Okay, some part is not still better because of like network part, but it's obviously optimized part. So this is the complete optimized approach for solving the problem in my way. So this were the approaches, two approaches for solving the problem. If you like the way I mentioned, explain the problem, like the video. And if you also want to check other questions, I'm also trying to get like upload daily questions, daily to daily, by keeping the streak. For following that along, subscribe to the channel. And thank you very much for staying till the end. Thank you very much.